We're going to add a loading skeleton or a pending UI to our movie app we created a couple of weeks ago, where you could search your movies based on a specific title or a specific character, where it would just communicate this user interaction via the URL to your React server component, where you're actually fetching the data and then show the result. Now here we're not showing any loading skeleton, so if you change this for a different topic, it just waits for that fetch to happen and then shows the result over here. Now we're going to make it to look something like this. So if I search for that specific term here, you would see a loading skeleton first before we're actually fetching the movies, and then we're going to see the result. So we see this loading skeleton and then the result. It also works when we're paginating. So when we're going to the next page, again, that's a different video. I'm going to link both of those videos in the card so you would know how we ended up with this movie app in the first place. In this video, we're going to just add this loading skeleton. So whether you're paginating or you're searching for a specific movie, you're going to see a loading skeleton before fetching the result. So let's jump into the code and see how we have implemented this. So let's continue where we left off in the previous video. Just a quick recap, if you haven't watched that, we had a NextJs application that works with Tailwind, and we were using MongoDB as our database. We had this movies page where we were using server components to actually fetch our database to get some movies and then render them down here as this movies list. We had this navigation or pagination buttons to go to the previous page or the next page by passing in search parameters to the URL for the page number that we are on, for the limit or the amount of movies that we want to fetch every time, and also passing in a query where the user is actually trying to type in a title or a specific actor to then search based on that term. Now, the first thing that we're going to do in this is to extract this movies list into its own component. So let's just cut this out of here and create a movies component where we can just get some movies and make or render a list out of them. So let's just bring that inside here. And now this would require the next image. So we're going to get the next image, and let's say we also want to get this movies as a prop, and we're going to type this movies. It's going to be type of MongoDB documents or undefined. Let's just also get this from MongoDB. Let me also capitalize the name of our component, and then let's go back to our page and import this movies component that we created. Now we need to just pass in the movies that we're fetching up above down here. So going back to our application, let me just close that deployed version. So going back to our application, if I refresh the app on the movies, everything should work the same way because we are just basically extracting that movies out. And the reason why I'm getting this movies out is there's two things that we can do here. Now, from a high level inside of this movies segment, we do have this loading.tsx file, which is a special file from NextJs that allows you to wrap your route segment with suspense boundaries. So if I refresh this page, you should see that loading UI momentarily before this shows up. Let me just go back and maybe again to the movies. You see that loading pops up for a second before this page is rendered. But on top of it, I don't want to see that loading necessarily. I want to see this list, as you saw in the beginning, show some loading or pending UI while we're actually doing a search. Now, one way to do it is to actually move this logic, this function, inside of this component. So this asynchronous task of fetching our database is happening inside of this movies list. And then we can wrap this component with a suspense boundary of our own. So we're going to get suspense from React. We're going to wrap this movies component with suspense where we can show a fallback UI to say, for example, loading from suspense while that fetching is happening. So let's actually do that. Let's get this function and actually move this function inside of our movies, where instead of receiving this movies as a prop, we're going to actually fetch this movies inside of this component. So let's also turn this into an async function and import the get movies from our library. Now this requires the page delimit that and the query, which we have inside of our page. So this page limit and search query is what we're reading from the search parameters object, which is passed to our page component. So we can maybe go ahead and send these down to our component. So we can go search is the search term, the page number is the page, and also the limit is the limit that's passed to our URL. Now inside of our component, we just close this off. We can say we would expect a search, a page, and a limit prop over here. Let's also type this. The search is going to be of type string. The page is going to be of type number, and the limit is going to be of type number. Now what we have done is to move the data fetching logic inside of this movies component, where we can actually wrap it inside of a suspense boundary. So while that asynchronous task is happening, we can show a fallback UI. This is giving me an error because the search can also be undefined. Let me just also say this is a string, or it can be undefined. Going back, let's save this up. Now again, this should work the same way. And now if we actually go ahead and refresh this to get rid of the cached version of our component. Now if I go ahead and put in some search over here, we still don't see this loading from suspense text showing up before we're actually performing the search. So if I change the search, I still won't see anything. Now your first guess might be that this segment is rendered statically, and if we opt into dynamic rendering, we could just fetch this or render this component every time at request time. Therefore, we're going to see this loading or pending UI inside of our suspense. So you might go for a solution like exporting a dynamic const. These are route segment config options. You can export from a page that define the behavior of that page. For example, here we can set it to force dynamic to force a dynamic behavior. So let's just test this out, but I'm going to come back to why this isn't going to work either. So let's just search for Jim Carrey. And now again, we're not seeing any loading skeleton or that text that we fall back to from our suspense. Now there are two reasons for this. The first reason is your page was already dynamic because you're using the search params object inside of your component. So there are two different ways or three different ways that a page would be opted in a dynamic rendering. One is to use dynamic functions such as headers and cookies. The other one is to use the search parameters object. And the third one is to have data that's not static. Now we're not going to dive into that, but all I'm saying is your page was already dynamic, but this isn't because your page is a static versus dynamic. It's because there are different levels or types of caching happening in NextJS. So if you head to NextJS's documentation, where they explain about this different caching behavior under this caching section, you can see there's 4 levels or 4 places, different places for this caching, from the server all the way to the client. So you have your request memoization. This is your fetch request caching, or the cache function from React to just store the result of your requests. Data cache, or the full route cache that happens on your server to store the result of rendering your React server components and the payload to improve performance. This is a persistent cache and also can be revalidated. This is the cache that you are targeting when you're exporting route config segment options, like what I did here with the export const dynamic and set it to force dynamic, or maybe setting a revalidate from the page. Now there's another type of cache happening on the client side, This is not persistent. It's based on the user session. So it lives as long as the user session inside the browser. And it's called the router cache or NextJS cache. This is a NextJS specific cache, which is going to store or cache the result of your React Server components payload. So therefore, it's not refetching or sending a request to the server to get the same component. This cache is the reason why we're not actually seeing our loading text or loading UI from our Suspense component, even though we're passing in these queries to our URL. It's because the result of this React Server component payload is cached inside the browser with the router cache. So even when we're changing the URL, it's not hitting the server with a new request to refresh or recreate this component, which is really what we need for this Suspense to kick in to show this fallback and then replace it with these movies. It's just using the result of what it already had inside the browser. And the only thing that's happening again is this function calls to fetch the data. So we see the fresh data, but the React Server component or the structure or the tree doesn't change. So it uses that cache. Now, how can we get around this router cache? If we go back to the documentation and move down to this router cache, first off, it's very informative to actually read through the whole caching behavior to understand these different levels. But if we just jump into the router cache, this is what's happening inside the browser. They explain what exactly is happening here, the duration, and what you can do to invalidate this cache. Now, there are two ways mainly that you can invalidate the router cache, or the NextJS cache in the browser. First off is inside a server action, you can use the revalidate path or revalidate tag functions. As you might have seen in the server action video we had on the channel, we use these two functions to refresh a specific route segment or to regenerate this payload by calling these two functions. The other way is to use cookies inside of your server actions. This is again because these are dynamic functions. It's going to invalidate the cache, which causes that route segment to be invalidated. The other way that we can refresh or invalidate the router cache is to call router.refresh, which is going to again invalidate the router cache and make a new request to the server for this current route. This new request is just going to go to our page and run this component. It's going to hit the Suspense, show the fallback, and then swap it with these movies when the data fetching actually is finished. So let's test this out first before we go about implementing a solution for this. So if I refresh the page now, you should be able to see that loading text for a second. To make this more visible, let's actually go inside of our movies where we have this get movies. Let's actually await a new promise here so we can make this to wait. Let's get a resolve function and call the set timeout, and then here we're going to call resolve in, let's say, 2 seconds. Okay, this is just going to make our function. Again, this get movies function, if you haven't watched the previous videos, inside of our library is our database access functions. There we are getting a handle to our database and then performing a search aggregation, which allows us to search for movies. But before I return the results, I just want to wait for 2 seconds so we can see this loading spinner. So if I now refresh this page, we should be this loading from Suspense first before this loads. Now, this just proves that the problem preventing us from actually seeing the results of this fallback is because of the Next.js or the router cache. Now, in terms of a solution to get around this router cache to be able to show a loading UI, we're not really using any server actions inside of our app to be able to use this revalidate path or tag functions. And there isn't really any place for me to call this router.refresh. Now, what I found to do the trick in our specific use case is to just pass in a key to our page component. So let's just generate a random number here. And if I save this now, going back to our app, as you saw there, if I now change this to maybe a different search query, you could see that loading spinner. And the reason why this is happening is because now this page component or the payload, which is cached in the browser, is not the same every time. So therefore, NextJS is not going to use that payload. Instead, it's going to send a request to get a fresh payload, which in turns call this suspense and shows that loading UI before actually rendering this movies app. Now, this is what I found to do the trick in our specific case. Again, if you're using a server action, this is easily done with this revalidate and revalidate tag, or other cases that you might be able to use this router.refresh. For me, just passing in this key to my page component did the trick. Now, you shouldn't be doing this on every page. And the reason why is you won't be able to benefit from that performance that comes from the router cache in the browser, because the whole point of this caching is to not send unnecessary requests for the same component to your server if you've already had the RSC payload in the browser. But so for some times or for some use cases, you might actually want to trigger a new request, as we've done it here. Now, let's just quickly replace this fallback with a skeleton that I've created before, so we can actually see a better skeleton here. So let's just go ahead and create this as skeleton here. So inside of the movies, I'm going to create a new file called skeleton. And here I'm just going to paste in this component. All this component is doing is just rendering that same grid list. And then it's going to show 10 of these list elements, which are just empty div and p tags to resemble an empty list item. So let's go back to our page, and instead of this loading text, let's actually bring in this skeleton and render this component instead. Now, if I go back to my app, you can see that loading skeleton, which is, by the way, using, going back here, it's using this animate pulse from Tailwind CSS. You can just easily animate this. So if I now go to the next page, you would be able to see this animation happening on this loading UI before the movies are actually downloaded. Now, we're done with what we wanted to accomplish here, but I want to mention something else, and that's a cool little component that I came across from Ryan Toronto. Just tweeted about this await component that he got or was inspired out of how Remix does stuff. And if you look at this tweet, actually shows an await component where it awaits a promise that you can send to it, and then it calls the children with that promise. So this is a pattern that we can also use inside of our application, whereby instead of fetching the data or moving this data fetching inside the movies app, we can just take this or leave this inside of our page component. So where it was initially, we were fetching it inside of our page component. We can just do the fetching there, but await the promise or send the promise down to an await component. So let me implement this so you know what I'm talking about. Let me just close this off inside of our movies. Let's just get this function out and back into the page component. And let's say here, what we're going to do is to, instead of getting the movies down here, we're going to just get a promise, and we're not going to actually await this. We just want to get the promise out, okay? Now down here, we can implement this await component. So we're going to create a new component. We're going to call this await. And let me just copy the code from here. So all this function is going to do is going to wrap a children, is going to await a promise that you sent to it as a prop. And once that promise is resolved, it's going to call this children function with the data. Okay, so with this component, let's just go back to our page. We can now wrap this movies with this await component. Now this is going to get a render prop and then pass this movies to this movies. Now we'd have to go back. So let's just save this up, close this, go back inside of our movies. Now inside of our movies, we no longer need this page and limit. We're going to turn it back to how it was before, where we was receiving this movies as an array of documents or undefined. So all really this little component is concerned about is receiving movies and rendering them in a grid list. Whatever data fetching we're doing, we're going to perform that inside of our page and pass the movies to this component. This is how we started. We were receiving these movies from our page and then rendering them down here. Now inside of our page, we are using this await component. We need to pass this a promise. So I'm going to pass the promise that we got from above to this component. And now what this await component is going to do, and by the way, this promise is the same thing that we got up top here. So we're calling get movies. We're not awaiting it here. We just pass down the promise to this await component. This await component is going to await the data and then call the children that you pass to it with that data as a render prop. So this is the render prop here. It's going to get the data. I'm just destructuring the movies out of it and passing it to this movies list component, which is just responsible for rendering these movies in a grid list. So going back to our application, if I now search for Godfather, let's say, the application should work the same way. Let me also refresh so we're not using the cached version of our component. And as you can see, everything works the same. So I thought this was a pretty cool pattern implemented by Ryan, where you would have this await component that you can pass in a promise to. It's going to await that promise to get the data and call your component when the data is ready. Now, one last thing before we wrap up, I prefer to use the UUID package instead of just generating this math.random numbers. So maybe down here for your key, you can just call the UUID function to generate a unique ID for your page component. So they're not going to be used from the cache. Instead, every time you're going to refresh this route by hitting your server and regenerating this React server component. That's a wrap for this video, folks. We implemented a loading skeleton or a pending UI while we were performing the search. And the idea was that instead of fetching the data directly in our page component, we could either move that data fetching logic down to the movies component or pass a promise to the component where we can then wrap it with a suspense boundary that triggers a fallback UI while that asynchronous task is being completed, and then swap it with the movies component. We also learned about different caching behavior or levels of caching in Next.js, and specifically the router cache, which is a Next.js specific cache happening inside the browser that stores the result of your React Server component payloads, and ways you can invalidate that cache by using the revalidate tag or path function, or the router.refresh, or by just simply, in our case, passing in a key to our page component. So therefore, when we are passing in a new search term or moving between different pages using our pagination buttons, it actually triggers a request to the server to re-render this page component. Therefore, it hits the suspense component, shows a fallback UI or a skeleton before actually rendering the movies. If you have any questions, hit me up in the comments. Like always, if you're interested in learning Next.js, I do have a course. There's a link in the description. Check it out. Let me know if you have any questions, and until next time, bye-bye.